All right, back to the same page we were on. It says, okay, this is supposed to be a pool full of water, and it says calculate base area. You're probably thinking floor area. You're not supposed to think floor area. You're supposed to think prism. If this is a prism, and this back section is the exact same shape. Actually, I think that would stick out a bit, wouldn't it? I don't know, maybe not. Maybe just like that. And then up here we'd have this part. I don't know if you can tell what that means. But on the back, we'd have this face that's completely congruent to this face here in the front. Oh, it's even blue for water. Okay, great. So we're talking about when we say base, they mean this front flat wall. And I know you're thinking, okay, why call that the base? Well, in geometrically speaking, the base has to be those two. And this happened on that first page that people missed a lot of stuff on. Yes, I'm still coloring. That the base is defined to be the two faces that are in a prism, the two faces that are parallel and congruent. So there's only two alike faces here, and that's this one and then the one that's identical to it in the back. So those have to be the bases. So base area is this flat thing. And it's a little weird. It's I don't know, sort of a compounded shape here. I kind of want to go rectangle plus trapezoid plus rectangle. This one's 8 by 4. That's not too bad. This one's 3 by, gosh, what would that be? I don't, oh, 3 by 2. Yeah, 3 by 2, so that would be 6. Great. But what's this area in here? Well, I know that this is a trapezoid. I know this little height here is 2. I know this whole height here is 8. So I got the two bases. I just need to know the distance between here and here. That would be the height of the trapezoid. If you think about this trapezoid on its side, this is the height, this is the distance between the parallel bases. This part of the edge of the pool was 4, if I look down here. This part of the edge of the pool was 3, and this whole length from this corner to this corner is supposed to be 15. So 15 minus 7 is 8. So I have a trapezoid there that's half times the height times the sum of the bases. So that's 48. 48 is the area of that part. So the area of the base is 32 plus 48 plus 6, which is 86. The volume of the thing then is just area of the base times the height. That's the volume. And that's going to be 86, which I just figured out. That was great. And then the height would be the distance between those bases, which here is 10. This is actually the height. It's the distance from one base to the other. Why did I put a plus down here? That was really silly. I destroyed part of my 6 with that eraser. All right, 86 times 10, which you can also do in your head, 860. Okay, this is a cool shape. I wish I could take responsibility for this shape, but I can't. All right, it says we've got, if you can imagine this, we've got, thinking from the ground up here, we have like a hemisphere, solid bowl kind of shape, like a half of a ball, but solid, so I shouldn't have said bowl. And on top of that, we're putting like a kind of a short and wide, like a tuna can kind of cylinder. And then once you glue those things together, you're going to drill out this cone. So it is kind of a bowl, but the inside of the bowl looks more like a funnel than a bowl. It's this very sharp kind of conical pit. And you're supposed to find the surface area. Find a formula for surface area, then calculate the surface area. Well, that just basically means have a plan. Again, let's build this from the ground up. I'm going to build from here. Say you're going to cover it. We're talking when I say build, I mean building the surface area. Means if you had this thing out of wood and you were going to try to paint all this stuff, let's just count it one section at a time. First of all, we have a hemisphere. That's that bottom domey kind of thing, but of course it's upside down. That would be all of this. Should I highlight it as I go? Oh, why not? Great. So I'm doing this part first on the outside. So this goes around the back, too. Can't really highlight the back in 2 dimensions, but that's this color. And then to that, I'm going to add the next little bit of area, which let's call the cylinder. So from there up to the top. And notice I'm not coloring the top. It's just kind of this band that goes around the whole thing. That would be that next piece of cylinder I want to calculate. Because when you calculate cylinder, you do lateral area separate from bases in the calculation anyway. So let's go lateral area of the cylinder, which I made in this color. And the reason I'm doing this carefully is because some people accidentally want to count this top circle. Well, remember, this top circle is empty. This is an empty hole. We can see in there into the surface of this cone. The cone is this stuff, but it also goes down inside. So I got to count all of this surface area. It's not the flat circle. It's only the sort of the inside exposed lateral area is all I have there. So plus lateral area of a cone. That's my plan. I have no flat circular thing on this face on this surface at all. I have blue is that sort of upside down dome. Now you can see the yellow inside there because that's the part that's inside that from the top. That's the inside of that cone that's drilling all the way to the sort of the bottom peak. Then I have the band around the sort of the rim of this thing, but if I'm standing here and looking at it, I can see this yellow face through the top open lid sort of thing. There's no lid, and I can see straight down if I was standing on top of this thing looking down. Okay, now you can't see the numbers. This diagonal edge of the cone is 8. The diameter of the opening at the top is 12. Oh yeah, I didn't finish my answer key here. This part's the yellow part. All right, so the surface area of the hemisphere is 4 pi r squared. Ooh, do I know the radius of that thing? Yep, it's 6. If the top radius is 12, then this radius would be 6. And that is also the radius down here of the hemisphere. Plus lateral area of the cylinder, which is perimeter, 2 pi r. I know the radius is still 6, times the height of the cylinder. Ooh, do I know the height of the cylinder? The diameter of the base of the cylinder is 12, and the height of the cylinder and hemisphere together is 8 feet. Now, wait a second. So this 8 you're telling me is that? Ew. Okay, this 8's in the wrong place. I was thinking that was the slant height. Well, slant height's 10, first of all. That's going to have to be 10 because this thing I just highlighted in red just jumped out at me. It's a right triangle, so that's nice. But the height of the... I guess that doesn't really look like where it goes. If I'm going from the middle of this, like from hemisphere height up to height, total height, this whole thing is 8. So the radius of the hemisphere is 6. So from center, this is center of the hemisphere. Center of the hemisphere straight down is 6. This whole thing is 8. The whole object has a height of 8. So this little bit has to be 2, and that's the height of the cylinder. That's kind of a bad picture. Lateral area of the cone is half PL, half times 2 pi r. R is still 6. And the slant height I just figured out was 10. Cool problem. I wish I would have thought of this. Volume would have been a lot easier. Volume, you'd just take volume of the hemisphere, volume of the entire cylinder, minus volume of the cone. But surface area is a little bit different. Surface area, as you drill out holes of things, you're usually adding to the surface area. Okay, so this is 2 times 36, which is 72 pi. This is 4 times 6 pi. This is 6 times 10 pi. Everything's in pi. Everybody's happy. I can add that all up. And I get 156 pi. Cool problem. Okay, this is a little bit wacky. Because of what they give me and what they ask me to find. The last thing I'm supposed to be able to find, like maybe one of the hardest things I'm supposed to find, is the height of the cylinder. They give me some base areas here, and they give me some areas. They tell me the surface area of the whole entire thing is 175. The part that's this is 25. Well, this 25 is the area of a circle. I'm tempted just from that to go, let's figure out, I mean, the thing I can get directly from that is going to be the radius of the circle. Radius of the circle then has to be 5. That's very powerful because if I know the radius of that circle is 5, that's also the radius of the hemisphere. That's also 5. And I can figure out what the surface area this is, and I'll know the surface area this is left from the 175. Okay. The 175 pi really comes from the area of the base, building this from the top up, the pi r squared. I shouldn't call it b, I should call it the circle, plus the lateral area of the cylinder. Let's just, in case you're totally stuck, what can you actually figure out here? Let's break down this surface area. It's the bottom base, which I know is 25 pi, plus the lateral area of the cylinder, which I don't know yet, plus the area of the hemisphere. Well, now since I have radius, I can find that stuff. First of all, this circle was 25 pi. This is the mystery piece right here. Let me make a formula for that because I'm going to need the height eventually. This is perimeter times height of the cylinder. Oh, wait, I know perimeter. Okay, life's getting better. This is 2 pi RH. Great. Oh, I know R. No, that's why I thought that was exciting, because I know R. That's 5 times height. All right, plus surface area of the hemisphere, which I know the radius, so I can figure that out. It's 4 pi r squared. Radius is 5 divided by 2. Okay, simplifying things a little further, I get 25 pi plus 10 pi h plus this is 25 times 4 is 100 divided by 2 is 50. Okay, remember this all equals 175 pi. So I can subtract off this 25 pi and the 50 pi on both sides. I get 100. Oh, that was pi. I get 100 pi over here equals 10 pi h. Any ideas on what you think h might be at this point? You guessed it. Divide both sides by 10 pi. H is 10, kids. Cool problem. Again, I like these. Okay, I was just going through the answer or the worksheet, and I realized, oh hey, there's answers at the bottom of that thing. And I was like, oh, you know what? I better just check my answers. And yeah, I made mistake number 2. It's this thing. Here's what I did. When I was doing the area of this trapezoid, I went 8, and then I looked up here, and I saw this 4. I saw this little right angle thing here. Looks like a 4. It's not. The length of that is 2, so this isn't 4. It's 2. Let me just fix that really quick. This is actually 2. Oh, I'm so embarrassed. At least I can admit my mistakes. Okay, just a second. All right, so this is... Oh, cool. It makes it look more like water. All right, when you erase that. So that area of that part is not 48. It's 40. So this isn't 48. It's 40. So it's going to mess everything up. Although the times 10 part's going to be nicely the same. This is 40. So this is 78. So this is 78. And this is 780. Okay, I feel better. Well, luckily I got all the rest of them right. Okay, so now we're talking about 30, 60, 90 based Prism. So yeah, there's some. I mean, be careful about that. I can see somebody actually doing pyramid. Longest leg also, that would be the side that's not the hypotenuse. The longest side not being the hypotenuse is the side opposite the 60. The height of the prism is 10 also. Okay, so I know that. So this face is actually a square if I ever wanted to know that. Draw another prism. I wouldn't make you do that. We talked about how net is something you kind of did in middle school. It's okay. If you want to see that, I will do it here. Where I said there, you kind of just like spread this thing out and draw all the faces. I'm going to separate out the lateral area as the middle. That was bad. The middle sort of side here. This would be the two bases on that 10, 10. See, I just like unzip these and flap them out so that they're flat. This is the 10 by 10 square. This is the short leg, and this is the hypotenuse of the right triangle. So there's the short legs face over there, and then the hypotenuse is supposed to be straight face over here. So if I wrap that all back together, I'd get the thing. I'd get the whole prism. Calculate the exact surface area. So it's the area of all this stuff. Remember, if you wanted to think that way, that's fine. Also, you could think in the way our book does, which is in terms of lateral area, which is this one great big rectangle, plus the two bases, which you can see there, the two triangles sticking off the top and bottom. To know the area of this rectangle, remember the height of it is easy, it's 10, but the length of this part down here is, if you think about it, the unwrapped perimeter of the triangle. So I need to know the perimeter of the triangle. Of course, you knew that was coming because we had a 30, 60, 90 and all that stuff. If this side is 10, that's the weird leg. That's the leg that's supposed to have square root of 3 in it. This leg here, which is, this one, it's the same as this one, is that divided by the square root of 3, which is not always fun. That's the same as 10 times the square root of 3 over 3, and then the hypotenuse is double that, so that's 20 square root of 3 over 3. Okay, so calculate the exact surface area. I'm going to do, like the book would do, I'm going to do lateral area plus two bases. Lateral area is perimeter times height. The triangles are half times base times height of the triangle. Now this height is of the triangle, this height is of the prism. Be careful about that. The perimeter here is all these things added up, which I got a minute. 10 plus 10 square root of 3 over 3. And it wants exact, so then 20 square root of 3 over 3 times the height. I haven't done that yet, times 10. Plus, well, the 2 and the half cancel. The bases of the triangle, I'm going to say, are 10 and 10 square root of 3 over 3. When I go to add these up, I can add those two things, but that's about it. I can add those two like terms. It becomes 30 square root of 3 over 3, which reduces nicely to 10 square root of 3. I can't add that to 10, but I can distribute this 10 and get those two things. This 10 that I'm distributing. Here, again, I just get 100 square root of 3 over 3. So, yeah, at this point, again, all I can add are the square root of 3 terms, of which this is like 300 square root of 3 over 3, and this is 100 square root of 3 over 3. So what I have here in those terms is I have 400 square root of 3 over 3. Great, that's it. But I just realized I did this wrong. Okay, I'm going to start this over in the next video. Sorry.